Good morning. My name is Gaurav Singh Rathod. My roll number is 2095181223 and my branch is Information Technology. Today we are going to discuss a concept, Introduction to Finite Automata. So from the subject Theory of Computation. The subject code is AITC01. So what is an alphabet? An alphabet is a finite and non-empty set of symbols. The example of alphabet is A, B, C, D, is order to Z. The elements A, B, C, D, Z are the alphabet. If W is equal to 0, 1, here 0 and 1 are the alphabet denoted by W. So, what is a string? It is a finite collection of symbols from alphabet. For example, if if summation A, then various strings that can be formed from summation are A, B, B, A, B, 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 A, B, A, B, etc. An infinite number of strings can be generated. So now what is a language? A language is a collection of appropriate strings. A language is defined using an input system. The input system is typically denoted by sigma. For example, sigma is equal to 0, 0, and etc. Any number of zeros. Example, the set of all strings over ABC that have AC as substring can be written as X, AC, Y, X, Y, etc. This is also be written as X belongs to ABC star modulus A greater than 1. The set of all strings over some alphabet summation with even number of A's is X belongs to summation star modulus of X. The set of all strings over alphabet summation with equal number of A's and B's can be written as summation X belongs to summation A star modulus X A modulus is equal to modulus A. So what is finite state machine? The finite state machine represents a mathematical model of a system that certain input. The model finally gives certain output. So the input is processed by various states. That states are called intermediate states. What is DFA? What is the definition of finite automata? So a finite automata is collection of five tuples q summation q naught f and epsilon, where q is the finite set of state which is non-empty. This summation symbol is input alphabet indicating input set, and this gamma is transmission function or mapping function. Q naught is an initial set, f is the final set. So this is, look at this is a automata diagram of a bank. Action in bolts are initiated by entity, otherwise the action are initiated by someone else received. So the automata only describe action of interest. To be more precise with the DFA, we should specify asks for all possible input. Example, what should the customer automation do if it receives or reading? These are with arrows. The typical behavior is if we receive an unspecified action is for the automation to die, the automation enters no state at all and further action will be called. This is a complete bank automata where initial transition state starts, then transfer, pay, redeem, transfer. When there are multiple automation for a system, it is useful to incorporate all the automata in a single one so that we can better understand the interaction. Called for the product automation. The product automation creates a new state for all possible states, for example, automaton. Since the customer automaton only has one state, we only need to consider the pair of states between a bank and a store. For example, we start in state is a, 1 where the store is in the start state and the bank is in the start state. From there we can move to the state a, 2 if the bank receives a cancel, or state b, 1 if their store receives a pay. Simple example, a way door. As an example, consider a one-way automatic door. This door has two pads that can sense when someone is standing on the front and rear. We want people to talk through the front and toward the rear, but no one allows to talk in one direction. So in one way door, A is nobody on either pad, B person on front pad, C person on rear pad, person on front and rear pad. We can design the following automation so that the door doesn't open if someone is still on the rear pad and hits the them. So this is the model of finite automata. Input tape. It is a linear tape having some number of cells. Each input symbol is placed in each cells. Finite control. The finite control decides the next state or receiving particular input tape. Next is type of automata. So automata are finite automata is defined are divided into two types: deterministic finite automata and non-deterministic finite automata. So D this deterministic finite automata, also known as DFA, there is only one path for a specific input for current state, and these are symbols: A machine number, Q is the finite set state, sigma is alphabet, gamma is transition function, Q naught is initial state, F is the final state. So uh, difference between DFA and NFA. So in DFA, for every symbol of the alphabet, there is only one transition state. Transition in DFA. DFA cannot use empty string. DFA has been understood on machine. DFA will reject the string if, in other hand, accepting state. Backtracking is allowed. In non-deterministic finite automata, we do not need to specify how does the NFA reacts according to symbol. NFA can use empty string transition. NFA can be understood as multiple line machines computing at the same time. If all of the branches of NFA dies or rejects a string, we can say that NFA rejects the string. Backtracking is not always allowed in NFA. NFA is easier to construct. So regular operations, a brief. We will cover this shortly. In arithmetic, we have arithmetic operation minus, plus, star. For finite automata, we have regular expression, union, concatenation, and star. Now we will see algebra of language. The union of two language is, so algebra of a language. The union of two language L and M is the set of string that are in both L and M. Example, if L is equal to 0, 1 and M is equal to 1, 1, then L union B is 0, 1, 1, 1, 1, 1, 1. Okay. The concatenation of a language is when L and M is the set of string that can be formed by taking any string in L and concatenating it with any string in M. Concatenation is denoted by ln, although sometimes we'll use L dot M. Pronouns dot. Example, if L is equal to 0, 1 and M is equal to epsilon 0, 1, then Lm is 0, 1, 0, 0, 1, 1 and 1, 0, 1, 1. So algebra of language, the closure star of clean star of a language L is denoted by L star and represented the set of strings that can be formed by taking any number of strings from L with repetition and concatenation them. It is a unary operator. More specifically, L naught is the set of we can make selecting 0 strings from L. L0 is always epsilon. L1 is a language consisting of selecting one string from L. L2 is the language consisting of concatenation selecting two strings from L. L star is the union of L0, L1, L2, L3 dot dot till infinity. For example, if L0 is equal to 0, 10, then L0 is epsilon, L1 is 0, 10, L2 is 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, L3 is 0, 0, 0, 0, 0, 1, 0, 0, 1, dot dot dot. Closure property of a regular language. So closure refers to some operation on a language resulting in a new language that is used for same type those originally operated on. regular in our case. We won't be using the closure property extensively here. Consequently, we will state the theorems and give some example. So the regular languages are closed under union concatenation and star. That is, if A1 and A2 are regular language, then A1 union A2 is also regular. A1 A2 is also regular. A1 star is also regular. Thank you. With this, we will conclude the topic. Thank you.